Hello, my dear. Welcome to IMS GATE Academy. I hope you are all good and your preparation going in the right direction. So, beta, we continue with the previous section and we start continuity of the thermodynamics, and we already discussed how to study the thermodynamics and also what is the what we will content here, that means concept of isolated system, property of system, thermodynamics process. So we will discuss today thermodynamic system. We will discuss today thermodynamic system. Yes, very good. Thermodynamic system. Okay, we will discuss today thermodynamic system, thermodynamics process and work transfer. And work transfer, in a work transfer, we will discuss work transfer. That means there is a displacement of a boundary, and also that means there is a non-flow work and also there is a flow work. See, my dear, when we study, first we study the thermodynamics process, one thing is very clear. What is that? Why we study individually this the process, thermodynamics process? मतलब हम इसको individually study क्यों कर पा रहे हैं? That means what is the speciality of this one? Okay, so we'll all discuss this one. Okay, so the thermodynamics process. See, very important. First of all, you keep in mind these things. Keep in mind what I am telling you. Thermodynamics process, it is not a real process. It is an idealized process. Okay, it is an idealized hypothetical process. Number first. Number second, it is a very infinitely slow process. Okay, and it may be called sometime a reversible process. So thermodynamics process, what is the characteristic of the thermodynamics process? Number first, please this point keep in mind, and while we are discussing the theory part, these all the terms we will clear. Okay, so first is it is a not actual process, it is a hypothetical process, that means idealized process. Number first. Number second, it is a infinitely slow process. Number third, it is a reversible process. When we enter into the reversible process, see beta, the reversible condition, that means a total reversible, that means internally as well as externally. But a thermodynamics process, it must be internal reversible. Internal reversible, that means a process, a reversible process must be a thermodynamics process, but the thermodynamics process, that means if there is a system, the process is thermodynamics process, that means it is a reversible. But reversible need not be a thermodynamics process. Why? Because it may be external reversible. Such type of things we will keep in mind. We will discuss, no problem. First we will discuss the thermodynamics process. So there is something is appear in the figure. What is that? See, there is a piston. This is your piston and this is your cylinder. Okay, that means we are taking a piston cylinder arrangement. Piston cylinder arrangement, and there are a 5 situations. Such type of figure again you appear in the preceding lecture in when we are proved that in that section we are a Carnot engine या Carnot principle. So ये figure आपको वहां पे भी देखने को मिलेगा. Okay, so this is your cylinder and this is your piston. See, what is the speciality of that? See beta, in general we know that if there is any system, that means if this is your piston cylinder and this is your piston, okay, and we take this is our system. Okay, this is our system and there is a stopper. Such type of problem we will also discuss in the numerical section. Okay, if we identify the system, if we label the system, that means you identify the property. That means system have some property. So it's have a property. Let's suppose x1 and y1. Okay, x1 and y1. It's a property x1 and y1. Any property x1 and y1. Okay, and at this point the piston, it is a static position. That means if there is a pressure inside the gas, there is a pressure. So how when we call that this piston is in a static manner, there are many processes. Either you attach the pin. This is the first process. Either you put the load over the piston. Okay, these are the method, different method. Or you may take a stopper like that. Why? Because a stopper, so that the piston is still at the point. So why we are calling that? Why? Because we identify the state during the thermodynamics process. We identify the state. Okay, so a state, when you find the state is a locus. State is a locus. State is a system property. So it is a locus. So when we identify the locus, you must have equilibrium. That means when you are traveling on the road and I identify your way, that means in each and every footstep we have a locus, so that I will draw your path in which you have to follow. Okay. So first we identify the locus. So if you identify the locus, we identify the state. So state, when we find the state at a equilibrium position. So let's suppose the piston, it is at equilibrium position. So when there is a piston and this is a cylinder and this is our system, so at this position we are easily to define the what? Property of the system. Let's suppose at this point the property is x1 and y1. Yeah, you may call that p1 or v1. No problem. This is the state property. This is the property of the system. Now, and we have to balance at this position, at this location. Let's suppose this is state point 1. Okay, state point 1. This is the practical scenario. This is your practical scenario, and how to draw a thermodynamics process from initial point to a final point, that we will discuss, that we are discussing here. Okay, so this is our system, and the system state property is P1 and V1. Let's suppose any property P1, V1, yeah, a temperature T1, P1, anything. What is the property that we have already discussed? We take any property. Okay, any two property, variable property. Okay. Now, when we if you find the state point 1, the piston is supposed to be a fixed at this point. That means it is a rest at this point. Okay, so we have to put the weight over it. Okay, we put the weight over it and we observe that what is the state at that point. So we observe that the state at this point is P1 and V1. Okay, so we have to draw a graph. We have to draw a graph. Let's suppose this is your pressure P and this is your volume V. This is the property. Okay, and this plane is called thermodynamics plane. Initially the pressure, why? Because there is a space is very low, small, so pressure is high, volume is low. So pressure is high, volume is low. So we identify this point 1, and let's suppose this is your P1 and this is your V1. This is your V1 and this is your P1. No problem at all. Okay, okay. We identify the state point 1. Now what happens if you draw the path, if you draw the thermodynamic process or a path, the process or path is the series of a static equilibrium point, series of equilibrium point. That means a locus. That means if you draw a path, you must have a locus. Otherwise, you cannot draw. If I am going from this office to home, what is my path? It must be have a locus. Okay, so when we are drawing the point 1, initial point to a final point, there must be a locus. So if you find the locus, the system must be a static equilibrium. The system must be a static equilibrium at a very small infinitely distance. Why? Infinitely small changes. Why? Because we don't want that it's lose the energy. Okay, that means if the state point 1 is there, now and there is a weight is there. This is our weight, series of a weight. How to assume this is a infinitely small? Put the sand. You assume that over the piston, this is our piston, over the piston we put the sand particle. Let's suppose we put the sand particle like that. You think like that. You think only this is a observation, sand particle. Okay, now, and you at this point you know measure P1 and V1. Now if you remove one sand particle, think like that. Remove one sand particle. What is happening? If you remove one sand particle, what is happening? The piston will little bit move up in a very slow manner. Piston will move little bit up. Okay. So if we remove, this is a removal. If you remove the weight, a sand particle, the piston will try to move. And we have to do, that means we have to do this activity infinite number of series, infinite number of stages. From initial to a final point, we have to do infinite. That means, see, if weight is removed, piston will move, and finally it will attain. This is your state point 1 and this is your state point 2. In between that, there is an infinite number of stages are there. Infinite number of the points are there. So, this is one point, in between there, and this is your final point. Let's suppose this is your final point. Pressure is reduced in this condition. That means there is P1, V1. How to define this? How to define the state of this one? You define the P1, initial pressure. Pressure will reduce. That means minus delta P. Volume increase, V1 plus delta V. So accordingly, we have to do the activities infinite number of series, infinite number of stages. So in that manner, we can find the locus in between initial point to final point. So let's suppose this is point number 1 dash. This is a 1 dash. Let's suppose this is a 1 dash, this is a 2 dash, this is a 3 dash, and this is your 2 final point. Let's suppose this is a 2. So you have to join this line. You have to join this line. Now, once you join this line, this is a process. Which process? Now, this is the process. Now, this is the process. That means this is the path. This is the path followed by the different state variable. Different state variable. Think like that. The path followed by different state variable. This is the state variable. Why? Because it is a property. Property is a state variable. These terms are always keep in mind. Properties are state variable. So state will change. Properties at a different stage. Okay. Right. Now, what we do? We are again reverse. That means we are do the activity reverse manner. That means what the amount you have removed, what the weight, what the amount you already removed on the piston, you can again one by one put on the piston. So it will shows that exactly same path will follow and the system will restore its initial point. See, this is not a practical scenario. This is not a practical. See, when the child is child is growing from childhood to old, slowly, it is not necessary that it is not practically that it will be again old to child. It is not necessary. But if child to old and again old to child, you have to do like that. That is called reversible process. That is called reversible process. Okay. So you think that it is not a practical or a real process. It is an idealized process, and that is the thermodynamic process. Thermodynamics process says that each and every equilibrium point, these are the equilibrium point. See, my dear, what is the delta P? What is the delta P? If the process will execute from one point to one dash point, one dash say one double dash point, when we can say the process is taking place, yes, there must be a change in property, and the process will taking place. That means process is happening. That means it must be change its property. Okay, and that process is happening either very slow or very fast. There are two categories. Process will happening either very slow or either very fast. Thermodynamically, accordingly, we can separate that One is the reversible, other is the irreversible. But when the property will change, in that condition, the process will change. In that condition, the process will change. That means process is happening. See, this is the process. In genuine, this is the process. When the process is happening, process is taking place, when the state variable, there must be a state variable. There must be a state variable. State will change. And that change either very infinitely small or fastly. It is not necessary. During that, the process will happen. Okay. So in this condition, see, if we want that this point is equilibrium, there must be a delta P tends to 0. What is the delta P tends to 0? This is called mechanical equilibrium. You all know that thermodynamic equilibrium have three conditions: thermal equilibrium, mechanical equilibrium, chemical equilibrium. We don't bother about the chemical equilibrium. This is forget for the chemistry and petroleum science engineering. So we were bothering about the mechanical equilibrium and thermal equilibrium. So this is the mechanical equilibrium. Okay, this is the mechanical equilibrium, tends to 0. Why not equal to 0? If you do the equal to 0, process is not happening. So when the process is happening in a very infinitely, this term, that means beta delta P. See, delta P tends to 0. What does mean that? Someone asks you, कि sir, delta P या any variable, state variable, any property tends to 0. What does mean that? Any variable, it is visible, I think. Oh, it is no. Okay. Delta P tends to 0. What does mean that? Please. What is tells that? This tells that equilibrium. That means beta, process will happening through a very infinitely small difference. See, if you take a difference P1 minus delta P minus P1. So P1 equals delta P. And delta P is a very minimum. Why? Because you remove a 1 cent particle. See, if you remove 1 by 1 cent particle, see the level of that change. That change, the level of that change is very, very, very small. So that the delta P tends to 0. And that is called mechanical equilibrium. See, what is the difference between delta P is equal to 0 and delta P tends to 0? Delta P tends to equal to 0 is absolute. In that condition, the process is, the movement is not happening. If you do the movement is happening, if you do the process will happen, there must be a delta P tends to 0. That is called equilibrium. That is called equilibrium, and that also called the static equilibrium. That means thermodynamics process. In that we can take it tends to 0. It is never. If you take delta T tends to 0, this is called thermal equilibrium. That means process is happening with a very infinitely small temperature difference. Process is happening very infinitely small pressure difference. This term is very clear about it. Okay. So again the process will repeat while we are putting all the loads over the piston. Same path will followed. That is called reversible. And mind it beta, we are not here to do any heat transfer. We are not to do any heat transfer. We are disregard the heat transfer. Why? Because heat transfer takes as external, and in this we will discuss the piston will move. How the piston will move? Piston will move due to the pressure difference. The piston will move due to the pressure difference, and pressure will exert a force so that the boundary of the system will expand. And in this condition, boundary of the piston will collapse. So when the boundary of the piston will expand or boundary of the piston will collapse during the static equilibrium manner, that means that is called quasi-static. We will discuss. That is called a work transfer. That is called a work transfer. We will discuss in the next slide, no problem. So during that, these all point are equilibrium point. This one are all the equilibrium point. During that process is called quasi-equilibrium process. Quasi-equilibrium process. What is mean by quasi? Quasi matlab almost. It is almost, that means delta P tends to 0 almost. Quasi, that means almost equilibrium. It is not equilibrium. It's a quasi-equilibrium process. The process will happen. And the quasi-equilibrium process is also a reversible process. So what is the quasi-static process? If someone say you, what is the quasi-static? So there are, note point is there, always note, quasi-static process. Okay, quasi-static process. Quasi-static process. This process also you have to clear, मतलब ये process आपको फिर से clear होगी जब when we are entering into the second law. Okay, quasi-static. What is the characteristic? Number first characteristic. This is ideal process. Ideal process. Keep in mind, ideal process. That means these are the objective, previous year objective question. Okay, that means hypothetical. Hypothetical process. Hypothetical process. Number first. Number second, infinitely slow process. Slow. See, someone says that, sir, it is a slow process. No, infinitely slow process. Infinitely small slow process. Infinite. Number third, the reversible process. Reversible. Within bracket, very important, internally reversible. Internally, it is visible. Internally reversible. These are keep in mind. Okay, this is keep in mind. Okay. Okay. Now, and this is also a thermodynamics process. Thermodynamic process. These things are keep in mind. Okay, these things are keep in mind. Very important. I'm telling you. Okay, and these things clear time to time. If the classes are progressing, that things are also clear one by one. Okay, so don't bother about it. Okay, so this is the characteristic. What we call that? This is the characteristic of the quasi-static process. Okay. So here one note point is that we will discuss in later on. It must be internal reversible process. Very important. Internal reversible process. This is very important. I'm telling you. If you understand this thing in proceeding classes, in the further classes, you have to be a very good concept is there. Okay. So this is the thermodynamics process. Okay. Now, next one, very important. See, what is the linkage of this slide? See, when this is our system, yes or not? This is our system. When the load is removing, externally reversible. Yes, we will discuss in later on, but Atul, you are right. Your question is very right, but I think it is not a very good time to explain the externally reversible process. But if you want to something feel, I will give you. Okay, I just now give you. See, what is that? What does that mean? I will give you some feeling. Okay, no problem. I am happy to ask. Okay, see this one. See this one, beta. If this is our system, okay, this is piston and this is piston and cylinder arrangement. If this is our system, okay, this is our system, okay, okay, okay. Now see the beauty. Now we add the load here, okay, add the load here, okay, okay. This is very important about the external variable. This is very important concept is there. We'll discuss later on, but right now. And let's suppose this is okay, load, and there is a stopper is there. Think very clearly. This is the stopper, okay, this is the stopper. Now there must be a reservoir. This is a reservoir. This is a reservoir, hot reservoir, that is called source. The reservoir have a temperature, let's suppose it will transfer a heat, okay, it will transfer a heat from that reservoir to the system. Let's suppose the system boundary, if we transfer the heat, the system, let's suppose the system temperature is T, okay, system temperature is T. So must be this temperature, the reservoir boundary temperature and system boundary temperature, there must be a temperature difference. So this is a T plus delta T and this is T, so that it will transfer the heat, okay. Now very important, if you transfer the heat, so the system temperature will increase, okay. Now what is the external reversibility? If we supply the heat, immediate surrounding की बात कर रहा हूं, there is a immediate surrounding concept. If you supply the heat through a very infinitely small temperature difference, that means delta T tends to 0. During that process, if the heat will transfer, that in that manner the system is called external reversible. Now, and we remove the load one by one. That means the system pressure change P minus dP, and this dP tends to 0. Very important, tends to 0. dP, one second, dP tends to 0. dP tends to 0. See, so thank you, Sita, thank you. You always motivate me. Okay, so see beta, see dear, delta T tends to 0. During that temperature difference, infinitely small temperature difference, heat will transfer, and you remove load one by one. So there must be a small incremental, decremental. That means if the piston will move up, pressure will reduce. But that reduction of the pressure is very small. So due to this criteria, the process is internal reversible. And due to this criteria, one second, we change the pen of. Due to this criteria, the system is called external reversible. And if you add both of these one, this is called total reversible. Or, very important, or simply reversible. Reversible process. It is clear? Atul, got it? Okay. So, hi Sita, how are you? Sita? All is good? Okay, so this is, and we will discuss later on after that. This is the very good concept is there, okay? Now, I think Isita is not present in the class, okay? Yes or not? Now, see my dear, okay, focus on this slide. See, when the system will expanding or when contracting in a quasi-static manner, see, the system will exerts a pressure on the piston. Yes or not, please? Yes or not? Yes, sir. Okay. System will exerts, change the system will exerts pressure on it. System will exerts pressure on it. Yes. System will exerts pressure on it. Okay. So that pressure is try to move the system boundary. Move the system boundary. That means it is not a movement, it is a displacement kind of things. Okay. That means the boundary will displace. Yes, there are four bounded by the four boundary. This boundary, and this boundary are fixed, but this boundary are moving. That means it will expand or it will collapse. During that manner, if the process is happening, that is called a thermodynamic work. That is called a thermodynamic work. And mind it, it is not a mechanical work. These are the very important things is there. See, if you think that thermodynamics or work transfer, that is called thermodynamic work. This is called thermodynamic work. This is called thermodynamics work, also called work transfer. That means it is a boundary phenomenon. It is a boundary phenomenon. Now, how to measure that work? We are discussing about when the process, now we successfully studied, sir, yes, the process is happening during the quasi-static process. Now, when the process is happening due to the pressure difference, and that pressure difference will, that means, see, when the something is expanding, something is compressed, there must be an energy transfer, and that energy transfer is work transfer. Why? Because there is a displacement of a boundary. So, we will visualize that there is a very important, I am telling you. See, if you see this slide, beta, in this slide, okay. In this slide, there is a, this is your shaft, yes or not? This is your shaft, okay. This is shaft, and over the shaft, there is a string, wrapped string over it, and one end is wrapped and other is attached to a load W. That load will exert a downward force, mass of this m into g. Okay, m into g. Now, okay. Now, if this shaft, if motor is on, that means we supply the current into it, the shaft will rotate, and the shaft will rotate. That means this shaft, if the shaft will rotate, this will winding. That means this weight will move up. We are lifting the weight. That means this is the displacement of the body in this direction. Displacement of the system. You call this is our system, okay? Displacement of the system. Okay, displacement of the system. And that displacement against a resistance. This is your resistance. That displacement against a resistance. Okay, this is clear? Okay, Atul said if thermodynamics work, always raising of weight is required, or it just no, always not. It's a just understanding. You are right. See, this is see what is why you are asking the question is that I know that logic of behind that in each and every textbook this example you have look at that this example, मतलब आपको ये example मिलेगा each and every textbook, standard textbook में. So why this example is given? Why? Because this is a classical. This is the origin on which this classical example origin से ही हम thermodynamics work को समझ पा रहे हैं. We understand the thermodynamics work due to this origin, but it is not necessary that We always understand like that, okay? But in why we are taking this example, this the thermodynamics work, the explanation of thermodynamics work through this understanding. Why? Because this is the best example suitable for that. Why? Because you learn the mechanics. Through the mechanics, you go to the thermodynamics. This is the beauty. This is the mechanics, simple mechanics. Yes, sir, weight will displaced and the resistance will down. These are the mechanics. So you can better feel. So that I will take this example, okay? I'll take this example, okay? Now, but it is not just, it is a just understanding. It is not required that, okay? It is a just understanding, okay? It is not necessary that this is the way, only way to learn the thermodynamics. No, it is not that only way, okay? Okay. Now, what is that? What is that, beta? See, this is very important line. This line is very important. This line is very important. What is that? See, beta, work is done by the system. See, this is our system. So work, this system will done a work. This line is very important. The work done by the system, okay? If the sole, that means total effect, that means sole effect, total effect on the surrounding. This is our system, so this is our surrounding. These all are surrounding. These are the surrounding, okay? So sole effect on the surrounding, okay? That means, see, if see here, this figure you can see here. If see beta, if the system boundary will displaced, during that displacement, it will displaced against anything. Yes or not? It will displaced against anything. That against anything is the resistance. And that resistance is any kind of the resistance. Either you put a weight, either you put, there is a atmospheric pressure, either there is a friction, any kind of resistance. If there is a resistance, there must be a work. Okay, there must be a work. So, see, see, it is a natural phenomena in the nature. When you are doing anything against the resistance, that you gives the more happiness as compared to the another situation. When you are come back through a resistance, that gives a very motivation. That means actually that is your potential. That means if you do if you judge your potential, you must have a work against the resistance. That judge your potential. So that's why this is a very natural. That means thermodynamics work say a very natural phenomena. That means, see, your potential will come out from the system when you do the work against the resistance. This is the natural law. This is the nature. In the classroom, there are many students there, and one day I give a very simple question paper and you do all the question and come out the examination hall. Second day, I will set the very tough question and you do very perform and come out the examination hall. Which paper you have to remember? Always tough paper you have to remember. Why? Why? Because you work against the resistance. That is the actual. That means this is a very natural phenomena. Okay. So, if there is a no resistance, thermodynamics say that if there is a no resistance, there is no any work. If there is a resistance, then there is a work. But the mechanical work is not. See, if there is a mechanical work, that means if you apply the force, if there is a block, mechanics, if there is a block, if you apply the force and you have a displacement, then there is a work. But thermodynamics not says. Thermodynamics work says that if you apply the force, work is the force, general fundamental, work is the force into displacement. But that force is not an applied force, it is a resistive force. Thermodynamics, it is a resistive force. That means the force is a resistant kind. If there is a no resistive force, but there is applied force, there is no any thermodynamics work. It is very clear. It is very clear, okay? So, so work is done by the system if the sole effect on the surrounding could be at the raising of weight. That means why you are raising? Why? Because if you raising the weight, that during that raising of a weight, you have actual potential. See, in the gym, if you are doing a gym, if you lift the weight you lift upward and weight you lift downward. In which condition you have to feel great effort? If you lift upward. That means if you lift upward, you always do something against resistance. Okay? So that means called a raising of weight. Okay? And that will measure the thermodynamic work. That means what is the line in this meaning? The line in this meaning is that a system have a sole effect on the surrounding when there is a raising of weight. Right. What is that raising of weight? See, this is very important line. I'm not writing here. Why? Because it's take a time. So the very important line, what is that, beta? There are a gravity, yes or not? There are a gravity, G. There are a gravity which pulling down, and we are overcoming that resistance. Why? Because gravity create a resistance against a motion. Why? Because motion it is there. So, and we are overcoming the resistance. That means we are going against the resistance. That means we are going against the resistance. That means there is overcoming. To make the displacement, that means we are overcoming the resistance to make the displacement. That means if the body will displace against the resistance, that is meaning by that. So if there is a displacement, this is very important. So if there is a displacement, then if there is a activity, displacement in a natural, if there is a activity, if there is a displacement, that means if there is a activity, if there is a activity against the resistance, that means you do something against the resistance. You do something against the resistance. That means you have a potential against the tough situation. You have to do anything against the tough situation. That means displaced against the resistance. Then the thermodynamic work is done. This is very clear. Then the thermodynamics work. So it is different from mechanical work. Very important. It is different from mechanical work. Okay. Now we have to understand like that. See, you feel better when you go through this slide. Yes. See this one. This is very important. See this one. See, we take one example. Okay. Free expansion or unstrained expansion. If you take one example, free expansion or unstrained expansion. What is that? See it. See, there is a chamber. This is your chamber. This is your chamber. This is your chamber. Okay. It is visible, na? Ha. This is your chamber. Okay. And we have a partition. This is a partition. This is a very thin layer of this one. We have a partition and we make a two compartment. We create a two compartment, compartment first and compartment second. Okay. We create. And in this compartment, there is a vacuum. Vacuum कहने का मतलब क्या? Not a negative pressure. Absolute vacuum. मतलब that means there is no any gas present. That means absolute vacuum मतलब P is equal to 0. That means in this condition P equal to 0. There is no any pressure exerted by this compartment. Okay. Now in this compartment there is a gas, so there must be a pressure P. Think like that. Okay. This compartment you have a complete vacuum. How to complete vacuum? Through a pump you can create it. Okay. Through a pump you adjust a air pump and you suck all the gas. And you have diaphragm. There is a diaphragm and there is a layer. Now, what you do? See, how to relate that a thermodynamics work? You puncture it. Very important. You puncture it. If you puncture it, automatically, due to the pressure gradient, natural process, the fluid is flowing from high pressure to low pressure. That means low pressure, that means zero pressure. That means there must be a pressure is flowing. Yes or not? like that, the fluid is flowing, the fluid is escaping, okay, like that. Okay. Now, that means, what is that? That means this gas will expand, yes or not? That means this is an expansion. Expansion, that means activity. You may say that activity. Yeah, you may say that displacement. Yeah, you may say that movement. That means expansion, activity, displacement or movement of the system. But if we expand this system, there is nothing to resist it. There is nothing to resist it. That means this activity will happen when there is no any resistance. That means if you create a vacuum, that means this chamber will not create any resistance. Any resistance. Any resistance. Then that means you do the activity against zero resistance. No any resistance, no. That means zero resistance. Zero resistance. Zero resistance. That means in this case, the system will not, see, the system will expand. Yes or not? The system will expand. But during the expansion, there is no any work transfer. And if you do the chamber is insulated, there is no any heat transfer. So what is the characteristic? See, if we are doing this chamber is insulated. So in this condition also there is no any heat transfer. That means if there is expansion, the temperature will reduce. If this gas will expand, temperature will reduce. There may be chance that outside temperature is high, so heat will transfer. But we cannot. We have to do insulated. So in general, anywhere, if you see the expansion term, in general, heat transfer is zero and work transfer is zero. These two things are very clear. This is not necessary. In the free expansion, this is not necessary. It is not necessary, very important. But this is a necessary condition. In the free expansion, work transfer is zero, is a necessary condition, but the heat transfer is zero, it is not necessary condition. When it is necessary, when there is insulating chamber. Okay, this is clear. Now, someone asks you, if there is an expansion, the property will change. Yes, property will change. Pressure P1 to P2, volume V1 to V2. But some other property may be constant. We'll discuss later on, okay, after we study the first law of thermodynamics. Now, so what is the conclusion is that? The conclusion is that, beta, so work done due to the displacement of a moving boundary. In this case, work is zero. This is the example. See, if this is a displacement, there is a displacement and it creates a force. See, this, due to the displacement, yeah, you may think that there is a membrane, and you may also think like that, beta. See, this is very important. If there is a compartment, and how to make this is irreversible? This is a highly irreversible manner. This is an irreversible process, okay? Why? Because sudden expansion, you puncture it, sudden expansion. But if you make a reversible manner, there is a different what is called? Different screening there. You screening very infinite number of you screening, okay? And if there is a system, and how to make this this is an irreversible process. Why? Because sudden expansion. But how to make irreversible? This we'll discuss later on, but you feel it. If you remove this slider, first slider, the expansion is slowly. Again you remove, expansion is again little bit more. Again you remove, expansion is again little bit more. Again you remove, expansion is again little bit more. And again you remove, expansion is. So that means expansion is a very slow manner. Expansion is a very slow manner. But during in this case, there is no any work transfer. This is the beauty. Why? Because in all the chamber, in this chamber, there is a vacuum. That means this is irreversible, this is irreversible. But if you remove the slider, the expansion against the vacuum, but there is a work. Which work? Mechanical work. Okay. Okay, there is a mechanical work. Thank you, Vijay. There is a mechanical work. See, if there, see, what is the work? Work is equal to force into displacement. Small displacement, ds. So this is there. Force is there. Yes, gas will exert a force on the slider. Force is there. And there is a small displacement, ds is there. So there is a work. But that work is a mechanical work. It is not a thermodynamic work. Why? Why? Because the displacement against a zero resistance. Displacement against a zero resistance. Okay? This is the beauty. So, it work transfer. This is so what is the thermodynamics work? If you do the thermodynamics work, if you understand the thermodynamics work, it is visible? Yes. If you done the thermodynamics work, that means work is equal to force. This is a very fundamental thing, into displacement ds. Yes, small displacement. Why? Because we study the reversible manner, quasi-static process. We study the quasi-static process, so very small. This ds, yeah, delta s, you may write delta s also. Delta s, and this delta s tends to 0. Very important. So this is a reversible manner. Okay. Now very important, this if this is work equal to force into displacement, but this force, if this force is a resistive force, then it is called thermodynamic work. Very important. Otherwise not. Otherwise not. So in this case, there may be a mechanical work, but it is definitely there is not a thermodynamic work. So it is very clear what is the difference between thermodynamic work and mechanical. Yes, it is come from the mechanical work, but the force which is responsible is a resistive force. That will separate from the mechanical work. Okay? Clear? Now we do the, so work done during the displacement of a moving boundary of a very important, this term we will clear later on, simple compressible substance. What is simple compressible substance? Anyone? What is the simple compressible substance in a thermodynamics? When we study the thermodynamics, what is the simple compressible substance? Anyone? Why we say that simple compressible substance? Anyone please? Anyone please? Simple compressible substance is a substance which is free from electrical effect, magnetic effect, surface tension effect. These effects, if the substance, what is the substance is there, and that substance have a no effect with respect to magnetic, with respect to electrical, or with respect to surface tension, or many other factors there, that substance is called simple compressible substance. It is not necessarily that's compressible, that means density change. No, it is not like that. Okay, it is very clear. Why we are taking this line? Why? Because in a very excellent book or very good book, this line you have to find out. Okay, this line always appear in that textbook. Okay, so this meaning will discuss in the later on, but at the time, what is the simple compressible substance? The substance which is free from the electrical, magnetic, and surface tension. That's it. Okay. Okay, work done. Okay, now under the quasi-equilibrium process, process called displacement work or thermodynamic work. See, my dear, that means very important. What is that? If you if you want a thermodynamic work, first you make the system is free from this effect, number first. That means that system is not a magnetic effect, electrical effect, surface tension effect, number first. That means you made a system like that, okay, number first. Now, if there is a displacement, if you want the thermodynamics work, boundary must be displaced. So you must have the displacement in a very slow manner. That means indirectly, directly, you make the system is reversible. That means first we make the system is a simple compressible substance. Number second, the process you make the reversible. During that, what you get, that is thermodynamic work. Okay, that is thermodynamic work. That's it. No other thing is there. Okay, that is thermodynamics. This is very simple and crystal clear. No confusion. Okay. So, if you write like that, कि sir, thermodynamic work, and mind it, very confusing term, thermodynamic work, or you can say that PDV work, displacement work, boundary work, anything. If you want this thermodynamics work, first make the system is simple compressible. Substance. That means this is free from electrical, magnetic and surface tension effect. Okay, surface tension effect, number first. Now you make the substance. Now to make the process reversible. Process. That means it is more accurate that quasi-equilibrium process. Quasi-equilibrium process. That means it must be internal. Then what is your outcome? Then what is you have, that is called PDV work. Very important. We'll prove it, no problem. So these are the very fundamental things, okay? Now, if you think that, sir, many people get confused here, many student community, sir, PDV work या displacement work is a reversible work. No, it is a kind of reversible work. There are many reversible works. PDV work is not only reversible work, it is a kind of a reversible work. This is a very important thing, okay? Always, it is not like that PDV work is a only reversible work. No, it is a kind of a reversible work. See, only reversible, how it is possible? Why? Because system is reversible or irreversible, it is our hand. You made it irreversible from the reversible. See, you made it irreversible from reversible. Irreversible to reversible, you made it. So it is your hand. So during that reversible process, you make a work, PDV work. So it is not like that it is only. If you made another kind of a reversible process, so it may be another kind of work you can achieve. You make a reversible due to displacement. According to displacement. So displacement will done due to the force, and force, where if the force will come? Due to the pressure. During that the work will come. So it is a kind of a reversible work. It is not a only reversible work. This is very important. So PdV work, it is a kind of a reversible work. Yeah, right? Not like that. It is not only, yeah, it is a kind of a reversible work. It is a kind of reversible. This is very important. This is very important. Okay. So how the system will make, how the process will done, and how the how we understand the thermodynamics work. So my dear, thermodynamics is most practical work. That means this is a more visualization work. That means, see, if there is a resistance, there is a work. Yes, it is like that. That means if you have do something, then you have outcome. If you do have something and something against, you have always do something against a resistance. It is a nature. In the nature, you do the any activity against a resistance. So thermodynamics is play like that. Okay. Now next. Okay. First of all, we prove it. The proof is very important. Okay. Thermodynamic work, the proof is very important. See, why the proof is important? Why? Because in this condition, there is a balancing of the piston. Okay. So what do we do that? See, see beta, there is a container. Okay, this is your container. Okay beta, yeah, you may say that this is a boundary. Okay, one second. This is cylinder. Okay, and this is your piston. Okay, this is your piston, no problem at all. And this is our system. Okay, this is our system. This is our system. We take this is our system. Okay, this is our system. And let's suppose this is your gas. Let's suppose system is gas. Let's suppose this is your gas. It is not necessary it is a gas. Okay, and this is your system boundary. Now, if you want that the piston is at the equilibrium position, at this position, yeah, if you want the state, you have to add load here. You have to add load here. Different load is there. Different load is there. Okay, different load is there. So there is one load. There is another load. There is another load. There is another load. So different load is there. So this is your load. Put over it. Okay. Now, this is the initial condition. You have to. Why? Because it is not. If you remove all the weight, so if we want that piston is not outside from the cylinder. So for that purpose, we attached here to a stopper. So what is the function of this stopper? First tell me. What is the function of this stopper? The function of a stopper is not allowed to move the piston further. That means due to the stopper, okay, beta, one thing is very clear. What is the function of the stopper? Number first. What is the function of the stopper when the piston will reach on the stopper? Number first. Due to the, when the piston will reach at the stopper, number first, pressure will increase, pressure will decrease, volume will increase, volume will decrease, yeah, volume is constant. What is your answer? What is the function of the pressure? When the piston reach at the stopper, when the piston will reach at a stopper, what is your option? Number 1, pressure will increase. Option 2, pressure will decrease. Option 3, volume is constant. See, there is no any heat transfer is there. There is only heat transfer. Let's suppose this is your heat transfer. So at the stopper, volume is fixed. So what is the function of a stopper? To keep the system, final system at a fixed volume. That means if you further increase the pressure by any mechanism, why you resisting heating, why you are supplying a heat, anything, why you stir the system, their process will increase the internal energy, either supply a heat, resistor heater, yeah, you stir the system, all the things, the temperature will increase. Due to that increase the temperature, the piston want to go up, but the stopper doesn't allow to go further. That means piston doesn't allow to go further, that means volume is kept fixed. So this is the function of the stopper, okay? We will discuss in the numerical part also. So if you there is a weight. Now if you remove all the weight one by one, if you remove all the weight one by one, that means if you remove this one, that means this will remove, okay? Remove, okay? The gas is our system. If you remove one by one, if you remove, what happening? The displacement is there, a small incremental displacement is there. So this is our moving boundary, yes or not? This is not a moving boundary, this is our moving boundary. Moving, okay, this is our moving boundary. No problem at all. These are the moving boundary. Now, what is that? What is that, beta? See this one. See this one. If you do the activity repeating, this boundary, this system boundary, that means this is a piston. Okay, this is our piston. That if you take, this is our system, only system, and above that, this is our piston, okay? No problem at all. You think like that, only very simple mechanism, okay? So this boundary will try to push the piston upward, yes or no? This boundary, system boundary try to push the piston upward through an incremental distance. Let's suppose through an incremental distance, let's suppose this is our incremental distance, series of incremental distance. This is a series of incremental distance, let's suppose dx, yeah, delta x. What is the difference between delta and d? What is the difference between delta and d? What is the difference between delta and d? Both are same. Don't bother about that. Sometimes we write delta, sometimes delta of triangle manner, or sometimes we write d. This is one pair. These are same. Sometimes we write this delta and sometimes we write d cut. These are the second pair. Very important, I'm telling you. This denote the property change. The upper one is denote the change in property, and the lower one is denote the transfer of the property. Transfer of the property, work and heat. So this is the boundary. This notation is for the boundary quantity of a boundary phenomenon, and this notation is represent the quantity of a system property. Very clear. So x is the property. x1, x2, x3 is the property. So either d or delta, anything you can write, okay? So we can write here d. This is dx, incremental distance ds, and this will apply this boundary, this is a system boundary. So system boundary will exerts. See, this system boundary here is the pressure is there, yes or not? Pressure is there. So this boundary will expand and little bit pressure will reduce. Okay, this system boundary is very near to the piston. So from there, this pressure will exist at any instant of a time. At any instant of a time. At any instant of a time, let's suppose the pressure is P. At any instant of a time, if you find anywhere, this is the pressure P. Okay, no problem at all. Now, what is the balance? Piston balance. If you do the activity of a piston, this is your piston, yes or not? This is our piston, okay, and from here, this is our pressure, yes or not? Will exerts on the piston. This is our pressure exerts on the piston. Who is responsible? Very important. Who is the responsible of this pressure? Who is the responsible of this pressure? The responsible is the gas pressure. So this is your gas pressure. Pressure or system pressure. Or system pressure. Who is the responsible? Gas pressure or system pressure. Now, let's suppose this is a mass. Why? Because there is a weight is there. Weight is there, including weight or mass of the piston. All we are include at a mass of the piston. So there is a mass of the piston. Mass of the piston is there. Due to itself, mass of the piston and weight of the load at any instant. Okay. So from here, beta, there is a weight. That means there is a weight downward. There is a weight downward. That weight is what is beta? M into G. That means mass of the piston into G, acceleration due to gravity. That means this motion of the piston against the gravity. This is very important. This notation is important. Why? Because the question which is framed in the GATE examination according to this diagram. Okay. So this is your G. This is your G, acceleration due to gravity. It is not a single arrow, it is a double arrow. Always acceleration denoted by double arrow. If you do the very correct manner, this is a double arrow. Acceleration is denoted by the double arrow. Single arrow denoted by the velocity or displacement. Single arrow denoted by the velocity, double arrow denoted by the acceleration. Okay, so this is the acceleration. Now, so this is the gas pressure P, and this is the weight of the piston, and let's suppose there is an atmospheric pressure. Okay, there is a surrounding pressure. Surrounding pressure or atmospheric pressure. Let's suppose this atmospheric pressure is P0. So over the piston outside, there must be atmospheric pressure P0, and A is the cross section of the cylinder. A is the very important. A is the cross section of the cylinder. A cylinder. How to find the cross section of the cylinder? How to find the cross section of the cylinder? A cylinder is equal to pi by 4 d square. What is the d? What is the d? D is the bore dia. D is the bore dia. D is the bore dia. Bore dia. Okay. So you have a cross section. So now you have this. What this diagram represent? This is a free body diagram of the piston. What is this called? Free body diagram of the piston. Free body diagram of what? Of piston. Of piston. Free body diagram of piston. Force balance. If this is your vertical direction, so summation of all the forces. What is the equilibrium? Free body diagram. And free body diagram, this is at equilibrium. At equilibrium. What is the equilibrium condition? There are 4 equilibrium conditions. Summation of all the forces in x direction, summation of all the forces in y direction, summation of all the forces in z direction is equal to 0, and summation of all the moment at any point is equal to 0. There are 4 equilibrium conditions. So there is a one direction motion. There is no any momentum, rotation is there. So we can the summation of all the forces in y, x, or any direction, y direction, and taking it is as upward as a positive is equal to 0. This is a equilibrium equation. This is not a thermodynamics. This is a physics. This is a physics equation. This is a physics equation. So what is the force balance? You made the force balance is like that. Okay, sir. What is the force balance? P0 P naught, that means what is P naught? Yeah, you can say that P of the gas pressure into cross section of the cylinder is equal to mass of the piston into G plus this atmospheric pressure force P naught into A. So what is the pressure of the gas? Pg, mass of the piston into G divided by A plus P naught. This equation is frequently used when you solve the GATE examination. Now, why we find this pressure? Why we find this pressure? Why we find pressure? And what is the physical meaning of this pressure? Anyone? This is the minimum pressure when the piston start to move. This is the minimum pressure. This is equilibrium. This is the minimum pressure. That means very small incremental distance. What is you have the pressure? This is the pressure. Very small incremental. Very small incremental distance. This is the pressure. What is the pressure? That means this is a very small pressure. That means this is a minimum pressure always. That means this is a minimum pressure of the system. Minimum pressure of the system over which piston is allowed to move up. Okay, piston is allowed to move up. This is the minimum pressure. Okay, no problem at all. Now, and this pressure, see, very important. This is the equilibrium pressure. This is the equilibrium pressure. Why it is equilibrium pressure? Why it is equilibrium pressure? See, mass of the piston is fixed, G is fixed, A is fixed, P naught is fixed. So this is a fix. That means at any point, this is a stage by stage. At any stage, this pressure is fixed. Yes, that means you identify the locus. That means from state point 1 to state point 2, if you draw the process, quasi-static process, the pressure will change, but that change is very small. That means during the quasi-static pressure, it is not necessary that pressure is constant. No. Delta P tends to 0. This is very important, and also there is a very confusing. If you draw any quasi-static process, very important, P into V, if you draw P into V and draw any quasi-static process from point 1 to point 2, mind it. So if this is your any thermodynamics process, any thermodynamic process, the pressure is not changing. That means this pressure is the function of volume. So that if you know the pressure, and according to the question what is given, you know the relation of the volume, pressure in relation to volume. Why? Because this pressure is the function of the volume. This pressure is the function of volume. This pressure and what is the relation of this volume, you can get that. Then you can find the work according to the thermodynamics work integration PdV. How it will done. Okay, no problem at all. First keep in mind. So it is okay. Now, if this is pressure into volume, always mind it. So what is the work dW? If you find, and we cut here cut mark. Why? Because this is the boundary phenomena. This is the boundary phenomena. What is that? F cross dx, yes or not? Keep in mind, beta, there is a very important thing. What is that? Okay, sir, this equation is very important. This equation is very important. What is that? This is very important equation. See, this is the equation. This is the. Acha, this is. If you write work equal to force into displacement, this is the thermodynamic concept or physics concept. This is the physics concept. This is the physics concept. Mind it. This is the physics concept, not a thermodynamic concept. Okay. So this work, and if this work, if this work is the resistance work, this is the mechanical, this is your mechanical work transfer. If that work will convert it into resistance, that is going to into the thermodynamics work transfer. It is very clear. Okay. So this is the resistance work. When you take this is a resistance, as a resistance, what is the effect? That means if you apply the pressure difference, during the apply the pressure difference, what the resistive pressure, due to that resistive pressure, what is the force? That is the force. That is the force. Very clear. Okay. So, and which is very important, I am telling you, this equation dw equal to f into dx, this is very important. This equation is applicable for any process. It is not necessary that it is a reversible process. Very important, I am telling you. Why? Because this is a physics equation. This is the physics equation. Work equal to force into displacement. Right? This is the work equal to force into displacement. And this equation is applicable for any process, either reversible, irreversible, any process, any kind of process. वर्ल्ड में जो भी process है सब के लिए apply कर दीजिए. Why? Because this is a physics equation. So this equation very important. I'm telling you, these are the very subtle concept is there. Okay, for any process. Okay, this equation is for any process. Now, it is okay? Now, this is for any process. Now, see my dear, that means work, see what is this mean for? That means work equal to force into displacement. Yes or not? This is like that. Work equal to force into displacement is for any process. Yes or not? This is for any process. Okay. Now, but this is the force, and if you apply the pressure, what is the pressure? What is the pressure? Simple. This is your piston. So what is the pressure? This pressure is equal to force upon area. Yes or not? Force upon area. So what is the force? Pressure into area. What is the force? Pressure into area. Very important. So from here we can write P into dA. Yes or not? We can write like that. Now, this P is not a constant, it is a variable. This pressure P is the function of V. Okay. So what is this, beta? What is this? This is your volume, incremental volume dV, not cut mark. This is your dV, volume. dV, incremental volume. Incremental volume. See, this not dA. Sorry, this is not dA. Sorry, this is not dA. This is A. Okay, A into dA is equal to dV. A, you know. So what is dW? So sir, dW is equal to P into dV. P into dV. Now if you find the, this is work, see, this is a, that means if you take any element projection, if you take any element, this is your dV, this is your dV, okay, and this is your pressure. This is at static equilibrium, the slope is minimum. So this is your P, this is your P. So P into dV is the area projected on the volume axis. So P is not a constant. The P is different at each and every location. This is more interception, this is very minimum equilibrium condition, okay. So that we kept P. So P is a not constant. That means this is not a isobaric process. This is a quasi-static. Why? Because incremental is very small element you select and you can integrate. Very small element. When you have a very small element, when there is a very small displacement. When you have a very small displacement, when you remove the load very slowly. And what is the effect when you remove the load very slowly? System is internally reversible. That means quasi-static. So if you integrate this one, work 1 to 2 is equal to integration dW is equal to integration P into dV. Integration P into dV. During the expansion, this is expansion. See beta, P is absolute. Always keep in mind, P is always absolute. P is always absolute. This is never negative. This is positive. P is positive. dV may be changed. That means expansion, volume increase, compression, volume decrease. So this dV will increase, decrease, pressure is always positive. So this may be, integration may be positive and may be negative. That means this work transfer may be positive, may be negative. And what is the convention? So from here, the sign convention is very important. Positive is what? Negative what? It is our acceptance. It is not necessary, it is a fix. It is our convenient to know that the positive, that means during the expansion, dV is positive, that means during the expansion, work is out. So work is out will take positive. This is positive. V2 minus V1 is positive. That means V2 is higher than V1. That means the system will expand. That means during the system will expand, work will positive. And when the system will expand, system will do the work on the surrounding. If dV will negative, that means surrounding will do the work on the system. So either work from the system to the surrounding or surrounding to the system. That will depend upon the sign convention, and it is our hand, what we assume, no problem at all, okay. According to this, P is positive. Mind it, this P is always in absolute pressure. Very important, absolute pressure. Always we take, okay. This is always absolute pressure, okay beta. So P into dV. Now, so this is important. Now, so this area will represent dW. That means this is a property which is not directly read by the locus, read by the area of the projection about volume axis. So what is the condition? What is the condition, see beta? So if we write some important point, so if you write some total boundary work, that means WB is integration V1 to V2 PdV. This is your equation, and this is your output work. This is output. Output work of non-flowing system. This is very important. Boundary work due to displacement of a boundary. number first. Okay, where P is the function of V, where P is the function, and very important note point is here. VVI. It is not necessary that it is for the closed system. It is not necessary that it is for the closed system. It is a kind of work of a simple compressible substance for the quasi-static process due to the displacement of a boundary. Due to displacement of a boundary, that means it is not necessary that a closed system. Why? Because see, if we take two systems, okay, this is our piston and this is our cylinder. So this is our system. So probably it is a closed system. Right. If we take this type of a system, that means in which mass is in, and we take this is our system, this is our open system. So in this boundary will displace, this displacement of a boundary, yes or not? And in this case, this is also displacement of a boundary. In both cases, this work is valid. In both cases, this work is valid. That means in this case, boundary also displaced. So what is the work on this piston? This work. In this case, the boundary also displaced. So what is the work done by the system on the surrounding a piston? This is this one. So it is not necessary for the closed system. Very important, I'm telling you. 99% students get confused here. So it is not necessarily for the closed system. So what is the condition? The condition is, what is the condition of this equation? The condition is simple compressible substance. Second is quasi equilibrium process. Third is what? Internal quasi movement of a boundary. That means displacement of a boundary must be of that's it. Okay, class suspend. Thank you. Bye bye.